Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to continue our tour of classification by focusing on decision trees. And decision trees allow you to represent rules to determine an action or a decision, and they're very easy to understand and also very popular in terms of predictive. Now, in terms of an example, perhaps we would consider maybe insurance claims. Now, we might have information for insurance. For example, we have the types of insurance that we have. We might have the age of the people making the insurance claims. We may have the amount of the insurance claims. We might also have the occupation of the claimant. What we may be wanting to do with those insurance claims is to identify fraudulent ones. So we may be having fraud. Is it fraud or not? So in terms of a decision tree, we might be able to get to the decision of whether fraudulent or not by looking at the combinations of the type, age, amount, and occupation. For example, for the type, we might have home insurance, we might have travel insurance, we might have vehicle or motor insurance. And for age, that could be your age of 25 or less than 50 or greater than 51. You might have the amount of the claim, whether that's $10,000 or whether that's 123 euros, whatever it needs to be. And occupation, that could be someone from sales, maybe some working in marketing, or maybe some working in IT. So what a decision tree would allow you to do is to chart some paths through these different things. For example, home insurance claims, which are from people less than 50 years old, which amount to maybe more than 10,000 euros, which are made by people that work in IT, may well be fraudulent. It may be that you find a case like that. So the decision tree effectively allows you to look at all the different paths that are possible through the data and ideally to identify the outcome. In this case, we're looking at fraud. Now, the way this works is that you need to have an algorithm that actually works out the relationships between these, and you need to have a set of real data where you know, for example, which ones are fraudulent and which ones are not, some historical data, and you use that to train the model to build a tree, and then you can actually use that tree to make predictions for the future based on a given type, age, amount, and occupation. Now, something quite important to note here is that you can have a number of different types of information used to maybe determine your decision or your fraud in this case. They can be either discrete, for example, home, travel, vehicle insurances, that's discrete values or classifications, or they could be continuous. For example, the age and the amount, these are more continuous numeric variables. What you would typically do in the case of continuous values is turn them into something a little bit more discrete to make them more classifiers. For example, by binning, as we've seen in another video, binning is possible with the PAL, and it's also possible with the predictive decision tree algorithms we'll see, binning to actually maybe group together, for example, less than or greater than 10,000. Otherwise, if your tree was actually done in each individual dollar or euro, it could be an enormous tree, very, very complex. And an important thing of the decision trees is to make sure they're easy to understand. The predictive analysis library in HANA supports a couple of different approaches to decision trees. The one we're going to see right now is C4.5. Now, this algorithm was created by Professor Ross Quinlan, and it uses the approach called information entropy in terms of how it works out and determines how the splits should be made across the tree. It in fact uses an approach called normalized information gain. Now, I'm not going to go into any details on that. You can find more details about the C4.5 algorithm from other sources. However, what I want to now show you is how we work with the C4.5 algorithm in HANA Studio itself. So now we're in HANA Studio. We can see that there are some claims information in a table. This is the data we're going to use to train our decision tree. So we can see, similar to the example we already saw, we've got policy, home, travel, and vehicle. We've got the age of the claimant. We've got the amount of each claim. we've got the occupation of the claimant, and we've got an indicator of whether or not this claim was fraudulent. And typically in insurance, up to 25% of claims are fraudulent. Here we can see we've got 3 out of 14. Now I've made a very simple, small data set for us to work with here to hopefully make it easier to understand and easier to see. But in the real world, this could be, or should typically be, having much more data and would be looking much more complex than this. We can see that we've got very nice discrete values for policy and occupation, and also for the fraud, yes or no. However, age and amount, they look pretty continuous. So that's something where we probably want to bin that to group the ages together, to or group the amounts to have less number of distinct values. That makes the tree easier to understand and represent. So that's our input data. So how are we going to work with that within the PAL? Well, let's have a quick look at some code. First thing we can see here, again, we set the schema to PAL as always, the schema. We have 4 different tables that go into the signature file. We have the input data, which is basically what we've already seen, but without the ID column. We have the parameter table that you're already very familiar with, and we also have the model. Now the model is what's going to be created when we perform the training process. We actually create the decision tree. The tree is stored as a model, and the PAL is able to store the model in 2 forms. It can store it in JavaScript object notation or JSON format, and it can also store it in PMML format. So you can then process that with either afterwards. Now the JSON one is important if you want to use the predictive analysis library to actually do predictions. That's the one that you would need to provide to another algorithm, which we'll see later, to actually use your model. So we're going to run this, and it's the create DT. For the C4.5 approach, we use the create DT, create decision tree algorithm. So you run that, and we create our code. We can see that we've created a view which is the same claims data we just saw, just without the ID column. So we've got first in the list, we have our attributes. So we've got policy, age, amount, and occupation. And the last one is the determinant. It's basically the fraud. Is it fraud, yes or no? So that order is significant. And we can see we've got 4 different ones there. We have to create our JSON and our PMML tables using a standard layout. You'll find more on that in the documentation. And then we've got a set of parameters that you would need to fill in. And for decision trees, we have the thread number, which you've seen many times and you're already familiar with, I hope. You can see the percentage. That's a way to tune your algorithm. You can also specify what's called the min-nums records, which is the minimum number of leaf items that you have. Do you have to have something in every possible leaf item or not? You can set it to 0 for no, or to 1, or you can set it to even a higher number. It's up to you how you want to do that. So maybe we'll put that here to 1. There's also, in terms of creating your output in the model, you can say is split to split across many lines, and you can give a line length as a value here. 0 means don't need to split. You can say whether you want to export to PMML or not. And as we have the age, which if we look at our list is the column number 1, we start from 0, 0, 1, 2, 3. Age is 1 and amount is 2. If we want to actually perform some binning, you can do that directly within the algorithm. So we can say that the column 1, which is age, is a continuous column. We want that one to be binned, so values up to 30, then from 30 to 50, and then 50 and above. So we've included 2 rows here to define how we would like it to be binned. If we don't do that, then the algorithm will do whatever it thinks best. And for the second continuous column that we've got, which is the amount of the claim, again, we've asked for that's column number 2 to be binned less than 500, 500 to 1,000, 1,000 to 2,000, 2,000 and more. So we've created 3 or 4 distinct values that we will have for those continuous values. And then in terms of the runtime, we just clear out the model tables, or the tables where the model will be stored, and then off we go and run, pointing to our input data and where we're going to put our models and our parameters. So let's go ahead and run that code. And it runs in just takes a couple of seconds. It's very fast. And if we actually now to refresh our list of tables, we can see that we've got some new tables, and one of them is the DT model PMML. And if we were to browse that, we'd actually be able to look at our model. So this is a PMML representation of the model. So you can see effectively the tree is defined within this model. Now, it's not something that's particularly easy for you to read, but another application or another solution is something that can process it. And if we look at the JSON version, this is something that the predictive analysis library not only creates, but also allows you to read. So when you want to process and make predictions using this model, the JSON example is the one that you'll provide to that algorithm. So let's go ahead and do that. So I've got another example of code here, and this is where we want to actually do some predictions. So this time we're creating a procedure using the predict with DT, predict with a decision tree. And this algorithm is the same whether you're using C 4.5 or anything else. It's the same algorithm. You would need to call this again when you set it up. You need to specify your input data. In this case, when you're predicting, you need to specify an ID, and then the 4 columns that we use: the policy, the age, the amount, and occupation. But that's all. And then you set up your predictions table, which will have the ID and your fraud column, yes or no for the fraud, based on what we already trained with the input data. We all call that through the wrapper generator. We need to create the tables, and here I've set up just 5 rows of test data that we can use to try to identify whether any of these 5 items might be fraudulent by passing that through our decision tree. Then we run the algorithm, and at the end I've just created a little view that takes the input data with the 4 columns and joins that together with the output data, which is where we say fraud yes or no, just to make the output a little easier to understand. So we now run that. It runs very quickly, and we can see from our select statement here, we've got the ID, the policy, age, amount, and occupation, and we've got whether or not it's fraud, yes or no. And we can see we've got 4 no, but the last one, so for home policies, age in the area of around 37, amount just under $3,000. For people that work in sales, there's maybe a high chance that that could be fraudulent. It doesn't mean it is or not. This is data mining. This is looking for potential or likelihood or probability. What that maybe tells us is that that is a claim that should be further investigated in more detail to find out maybe whether it's fraudulent or not, rather than investigating all of them, which would be obviously very difficult and heavy to do. So we've seen an example where we've created a model, we've trained a model using C 4.5, and then we've actually performed some predictions on that, all using the PAL within HANA. In the next video, we'll look at a second method for performing a decision tree.